Greetings everyone, hope you all safe at your home. In this video, I'm going to discuss one of the topic in Module 3 in Advanced Java Programming, that is Java 8 Streams. Java 8 is provided with many features such as functional programming, lambda expressions, concurrent operational functionalities, and streams for efficient programming pattern. Java 8 Streams is used to process a collection of objects. A stream is a sequence of objects that supports various methods in order to obtain a desired output in a thread-safe manner using the pipeline concept. But the main thing is that the input will be converted to a stream only if it is in the form of objects and not in the primitive type. We should take care in order to decide what thing is going to be converted to a stream. Should be in the form of objects. Once we collected the data from any source, it will be converted to a stream form through a stream generator, and the data in the stream should pass through 0 or more intermediate stream operations, and finally once we got the desired output, through a single terminal stream operation will collect the data in the desired format. Now consider this architecture diagram. So through the stream source, we'll get the data from the stream source is nothing but an array or a collection or an IO channel. Once we got the data, we need to create it in the form of streams, and the data in the stream has to undergo a sequential number of intermediate operations. In that operations, we have specified what the data in the stream should be converted to using some lambda expressions. So the data in the pipeline will be converted to one form to another form if it undergoes an intermediate operation. So once we got the desired output, in that stream, if the data is in the form of our desired solution, it can be collected from the stream through a terminal operation. So the terminal operation is the main thing in order to extract the stream elements to our console. And after that, we can do operations in a normal manner. So the main difference between a collections and a stream is in collections, we can add or modify elements at any point of time. But in streams, we cannot add or modify as it is a fixed one. Once you created a stream, you cannot add a single element or you cannot delete a single element. It is a fixed thing. And once a stream is completely emptied through a terminal function, that stream is useless. Again, if you want to use that stream means you need to create a new one only, as already created stream is not in the memory. Then the second point is elements in the collections can be accessed in any order. So we can access the intermediate elements with the specification of some index. In collections, we are having one method called get. Using get with the corresponding index value, we can fetch an intermediate element in a collection. But elements in the stream can be accessed only in sequence. Then coming to the third point, collections can be traversed in n number of times. As I have already said, once only streams can be traversed. And we can do external iteration and we can do external iterations to iterate through stream collection elements, but in streams it has to iterate the data in an internal way. We cannot do any iterations in the streams. Whatever operations we want to perform in a stream, that stream itself will apply that corresponding operation to the stream elements in a sequential manner only. So There are three ways to create a normal streams and two ways to create infinite streams in our syllabus point of view. So if you are using array, this is the main thing we need to know about the conversion of an array to a string. So this is nothing but an employee class. In this class, we have defined three data members and a constructor, and we need to add some of the getters and setters that you have already know how to create. So this is the concept of creating a stream from an array. In this thing, first we have created a group of employees in the form of arrays, and in the main function, we have created that array of employees into a string using stream.of. This stream is nothing but a class, and of is a member function of this stream. So the array of employees, this is nothing but the array name we have created that should be passed to of method in order to convert all these employees in the form of stream. So you can use either of these ways to create an array from a string. I mean to create an array in the form of string. Then coming to the second thing, we can create streams from a collection also. In this example, we have converted the array of employees in the form of list. So once we got a list, this dot string function will convert all the elements in the collection, that is nothing but here it is list. All the employee elements in this list, employee elements, that means employee objects in the list, and it should be converted in the form of strings, stream of employees. And the third way is to create a stream from maybe some input devices. Once we got, because if we want to collect an information from input devices, it should be in the form of step by step only. First we get the input, first input, and then the second input through the scanner class or wherever. So once we got all the data for a stream creation, as stream can be created only once and it cannot be modified. That is the basic property of a stream. So first we need to collect all the data in order to create stream. Once we got all the data, then the stream is ready to build. So for this concept, we'll use stream.builder. Stream.builder class is used to create a stream with individual values, or if the input is from some input source. You need to create an object for stream.builder class using a method stream.builder. This one is a class and this one is a method. So with this object dot accept method, you can give n number of inputs. You can collect it either through scanner class itself. So once you got all the inputs for the stream creation, then this object dot build method will create the corresponding stream of employees for further process. So in the previous concept, we have created stream in a finite way. We can create infinite streams also. So for that purpose, we can use iterate generate functions. So stream.iterate will give you a stream of series. So in iterate, you need to give two inputs. First one is the initial value and second one is the lambda expression for the next value. How to calculate the next value with the initial value. So in this example, the initial value is 1 and the second value is calculated by using 1 into 2. That is, the second value is 2 and the third value is with the previous value 2. 2 into 2, 4. So the series will be go on like 1, 2, 4, etc. etc. So in the using iterate method, you can generate series, that is different number of values you can generate with the iteration value. But in generate method, you need to specify a supplier. So you have already know what is supplier, consumer, predicate and filter. In the previous class itself we have discussed. So we need to give a supplier object in the generate function. So we'll get replicated values of that supplier. You need to give only one supplier and a supplier will return only one value and that value will get replicated in the form of series, that too in the form of an infinite one. In order to limit the number of values generated, we have some built-in methods. One of such method is limit. Then sequential streams versus parallel streams. So parallel streams and sequential streams, these both work similar, but the main thing is depending on the main difference is reflected in OS concepts. That is operating in the operating system will be handling the streams in such a way we have mentioned. If we created a sequential stream, that is a usual one and the default one, so only a single processor will handle all your functionalities. But if you have created the streams in a form of parallel one, so what are all the cores that is available in our system that will be taking care of executing different streams as they are independent. Oh, each stream value is independent one. So the streams will get access through different cores. That is nothing but processors to execute, and the data will be collected from the corresponding processors, which improves the speed of execution. So this is the example of sequential versus parallel streams. So in sequential, only a single processor will executing all the things. This is very similar to for loop iteration. So first an initial value will be processed with the set of statements which have specified inside that for loop. Once the first iteration has completed, it will proceed with the next iteration, that is the next I values. But in parallel streams, so the different iterations will be executed in different processor and finally all the corresponding thing will be collected accordingly. That will be handled by the streams itself. Next, how to create a sequential stream and parallel stream. Once we create a stream, dot sequential method will convert that stream into a normal, a sequential streams, and dot parallel method will convert the streams into a parallel streams. Once you specify dot parallel, the streams will be handled with different processor. If it is sequential, a single processor will handle all the inputs. So by default, it is sequential only. So now we are going to see what are all the operations available, stream operations, so that the data will be converted to a form to another form. So in for each for method, that is the simplest method, it loops over stream elements. So by semantic for each element in the string. That only this function means. So for each is a terminal operation. So once we have specified the for each method, the loop or the stream will get emptied. That is, the stream pipeline is considered to be consumed and can no longer be used. So in this example, a stream of string will be created with a collection names. After that, for each string in that stream, you have to specify a consumer in for each method. So consumer, you already know, with the input it need to do something, but it does not return anything. So for each n in that stream, system.out.println of n, that is, you need to print that corresponding value in the console once you get it from the string. And the second thing is map function. It produces a new stream after applying a function. That is, it transforms the stream of elements from one form to another form. This is different from map collection. Don't confuse it with map, collections map. Okay. Next. So for this is an example for a map function. I'll give you what to say, an example, runnable example in Eclipse. Before that, we'll know what is what. We see the things in PPT. Okay. So a stream operation map is used to convert the stream of elements from one form to another form. So in this thing, with the collection objects, that is a list, you're going to create so in this example, the stream of employee is created with an array of employee using stream.off method. Once we have created an array of stream of employees, so that stream will be passed to another function using the map method. In this map method, we need to give an input in the form of function alone. So this one is a functions lambda expression. You will get one input, and with that input, you are going to do some process, and you need to return a result in different type or the same type. That depends on our specification. So here, once you created the stream, that is in this at this space, this will be a stream of employee. Once it is passed to a map function and with the given input, the stream of employees will be converted to a string of employees. That is, with the employees, you are getting only the name of each and every individual employees. So after this thing, a stream of string only will be passed to the next function, intermediate function, and that is also passed to another map method. So all the names in the streams will be converted to uppercase. And finally, this one is another method. This is also a terminal method. So using the terminal collect method, the data in the string will be collected in the form of list. Similarly, we can create a collection, different kind of collection object also. That is nothing but to list, to set, to map. So what we need to give in the output, that depends on our specification. So finally, that list of employees will be printed over this thing. Next method is filter. So as a filter, it filters a set of values and only depending upon some conditions. So it produces a new stream that contains elements of the original stream that passes a given test that should be specified by a form of predicate. So this one is an example for a filter method. So here also with the same thing, with an array of employees, we are going to create a stream. So using filter method, we have given one predicate, that is input should be given, and finally we need to return a boolean value by processing that input with some relational operation. Okay, so it should return a boolean value only. So we have given some condition in order to filter some of data from that stream. So here what is going on means, so with a stream of employees, we need to check who are all the employees are earning more than 2 lakhs. So those who are earning more than 2 lakhs will be getting out of that stream, and the false conditioned employees are stay back in that previous stream also, and we cannot use those stream values in the forthcoming operations. So once you got filtered the employees who are earning more than 2 lakhs, and that will be collected to a collection object as we have seen in the previous example, and that will be printed in the console. So the next stream operation is reduce. So a reduce operation takes a sequence of input elements from a stream. It combines them into a single summary result by repeated application of a combining operation. That is nothing but reduce is a terminal operation. So once we have specified this method, the stream will get consumed. So what we are going to do with this function is, in this method, we are going to apply some binary operation by considering two consecutive elements in a stream, and we apply that binary operation with that input elements. We need to return an output element, and with the output element the next corresponding input will be taken and the corresponding binary function will be applicable to, I mean, with these two values, these two new values, and this thing will go on until the last element will be processed. So finally we will get a single entity only. So this is an example of this reduce method. So with the array of employees, we are going to create a stream, and with that stream we are going to apply a map method in order to get a name of employees alone. So here at this point the stream will be of a stream of strings only. So that stream will get passed to this reduce method. Once it passed through the reduce method, it will return a corresponding single thing only. So in reduce method we need to specify two input argument. First one is the default parameter and the second thing is a binary operator. So this binary operator takes two input, and that will be specified using one lambda expression what to do with these two inputs that we have specified here. And for the second iteration, the previous iteration's result will be placed over this location, and this value will be considered as this A, and the B will be the next consecutive element in that stream. So what we are doing in this example means we are concatenating all the employee names into a single entity, single string. So that will be stored in the names variable string names string object, and that will be displayed in the console. So next stream operation is collect. So it performs repackaging elements to some data. So what we have seen in the previous example. So using collect method, once the data in the stream has been converted to our desired form, that will be collected for our further usage in our respected form using collect method. If we want to use that final thing in the form of list means we need to specify collectors.toList, or if we want to use in the form of set collectors.toSet, to map, all the things are available. So collectors.toList used for collecting all the stream elements into a list instance, and similarly for set instance, and similarly for map instance. But to create a map we need to specify two things, as we have already seen in the previous semester itself. So we should need a key value as well as a value, key value and the corresponding normal value for that key value that we need to specify. And finally, grouping by method also there, in order to group some objects based on a particular property and store the result in a map instance. So this is an example of collect method. This is the same example what we have seen in the previous thing for a map method. And similarly we can convert these stream elements into a set with this representation, and similarly to a map by specifying what is the key value and what should be the normal value, that is the corresponding keys value should be specified over there. So with that stream of employees, what is the key and what is the value that we have to specify in order to create a map. So ID is of type integer and the name is of type string. So finally you are creating a map of this type. So group by method is useful in order to collect a group of a particular object based on a single property of that object. So with the stream of employees, we are going to collect group by will return a map instance only. So we have to specify based on which property you are going to create a map. So here we have specified ID property. So ID should be the key value. This is of type integer, and finally based on this ID we are going to group a collection of objects, that is employee objects. So collection is nothing but here list of employees. So finally a map will be created with ID as integer and the corresponding employee object as values. So this is the usage of grouping by. So and the rest of the stream operations are a simple one only. So these are all the C stream operations are built-in options. So with the help of lambda expressions, we can define what we need with the set of input. So distinct method, it returns a stream with unique elements. If you have replicated elements in a stream, that will be eliminated if we pass that stream to a distinct function. And similarly, count method will returns a total number of elements in the stream, and sorted method will sort the elements in the stream. So by the name itself, we can identify what this function can do. So these are all the examples of those three functions. So with the arrays or with this array of integers, we are going to create a list, and with the list we are going to create a stream of integers. Note down the point, stream of integer alone. So we need to create a stream of integer objects. So once we created a stream of integers, it will be passed on through distinct function. So the replicated values will get eliminated from that stream. And finally, after eliminating all the replicated values, so we collect the rest of elements from the stream using a collect method, and that unique list will get printed. So similarly, for the count operation, in this thing, what we are doing means we are going to use a filter method. So in filter, we need to give a predicate, that is a thing that returns either true or false. So what condition we have given here means we need to get each element in a stream, and we need to check whether that element is divided by 2 or not. It should return true if it is an odd number. So after passing this filter, only odd number of elements only will get passed to the next stream, and will get what are all the odd numbers present in that stream using count method. So and the third thing, sorted. So in this function, we are going to create a stream of integer, and that will get filtered to identify what are all the odd numbers. And once we got the odd numbers, we need to sort it, and finally we'll collect it to a list. So once we printed that collected list, all the numbers are in the sorted form. Some of other stream functions are any match, all match, null match. So that are the things we have specified in our syllabus. So all these three methods can takes predicate as an input and returns a Boolean output. So any match, all match, none match. So these methods can be used in condition checking places. Okay. So any match, it returns true if any one of the element in the stream that matches the predicate, otherwise false. So all match method, it returns true if all the elements in the stream matches that condition alone, it will return true. Otherwise, even a single element fails to meet that condition, this all match method will return false. None match method, it is just opposite to all match. So it will check whether all the elements in that stream fails to meet this condition. Then only it returns the true. So this is one kind of example. So we'll go with the live example. So these are the things we have already seen in PPT itself. With the array of employees, I have created stream using stream.off, and once I created the stream, I'm fetching all the elements in the stream and will display it in the console. Okay. So these are all the ways. Those are as in the PPT. So using stream method, we can create a stream from a collection. Using a stream.off method, we can create a stream from an array. And similarly, using stream builder method, we can create a stream of individual elements. Using iterate, we can generate a series. Using generate, we can generate an infinite replicated of the same value. So dot limit method, this limit method will reduce the number of series. So once we try to run this program, see, so this one is the stream created using arrays, and this one is the output of streams created using collection, and this one is so in this program I have displayed for each for this stream creation using arrays alone. So in this thing, using dot stream method and stream builder, I have created the stream, but I never displayed it. So in this output, this one belongs to this first thing. So the streams created with array of employees. After that, I have displayed the iterate method. So starting from 1, I'm going to iterate based on these conditions. I'm going to iterate 10 values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 values will get iterated and will get displayed using for each method. And using generate method, with the supplier input, it will generate an infinite series of same values what we have specified in that supplier. So 56, 56, all the replicated values only will get displayed, and this count will get limited with the help of limit function. After that, we have displayed all the things using for each method. So inside a for each method, we need to give a consumer alone. Next function. So this is an example of map function. So what we have seen here is, so we have created an array list object, that is an empty list, and a function. In that function, we are going to take an integer input argument and do some operation, and finally it will return an integer. So what is the specification here is, with an integer as an input, it is going to double the value. It is going to return the double the value. Finally, here we are going to add 5 elements to this list. So once it is converted to, once we have added all the elements, dot stream method will convert all these elements in the form of streams, and that stream of element will be passed through a map function. So these elements are getting passed through this function, and finally for each element in that stream, after that map function got executed, that will be displayed in the console. So this one, student details dot get all student details. This function we have already seen in the classroom itself. So this method returns a list, and with the list I'm going to create a stream of students, and I'm displaying what are all the students available there. Then here, this is for initial stage. Before map application, what are all the students state? And here I'm going to pass that stream of students to a map function. So inside the map function, for each student, I need to update the CGPA value with 0.2. That is, already some CGPA value is there that will be fetched from the corresponding object, and with that value I'm going to add 0.2, and that will be again placed back on the student entity with some corresponding setup function. So this has been specified with a return statement as it is a function inside the map method. So at this point, the CGPA of the individual students are getting incremented with the specified value 0.2. After that, for each student in that stream, I'm displaying all the students. So in this example, in this part, so I'm going to specify the same thing. I'm going to increase the CGPA value. After that, I'm going to filter some students who are having CGPA greater than 8.7. So this is an example for filter. So I have to specify a predicate over here. A predicate is nothing but taking an input argument of any type, and with that input argument it is going to perform some relational operation, and based on the output it will return either true or false. So this will filter some students based on the CGPA value who are having 8.7 and greater than it. Finally, those who got through that filter will get displayed using for each method. So in this part, what we have done is, so with that stream of students, I'm going to filter the students who are having or who belongs to IT department alone using for each method. For each method, I'm displaying all the students who belongs to IT department. And in this part, what I have done is, so I have created an array list object, and I have populated the list with some set of values. Okay, this we'll see later. Okay, we already discussed the concepts of all the methods, no? So this one, in this part, I have used reduced method. So what I have did is, reduce will return a single entity. So that can be displayed using system.out.println to the console. So what I have specified here means, with that array list, I'm going to convert or create a stream. So once I created a stream, I'm going to reduce that stream into a single unit. What I have specified here is, this one is a binary operator. So what I'm going to do is, with 0, 1 as first operation, I'm going to do 0 plus 1, and the result will be stored over here, and the second element 5 will be placed in spite of b. So 1 comma b will be passed to the second iteration, and this will get iterated till we reach the last element in that string. finally all the elements. This is nothing but to add all the elements in the string. So all the 5 values will be added and a single entity. The sum of all these 5 values will get returned from this reduce function, and that will be displayed to the console using system.out.println. So in the last step, what we have specified means stream.iterate. I'm going to generate a series, and I have generate only 5. I have limited it up to 5 values, and those values are get doubled using map method, and after that I'm going to display it. So let us see what is the output of this program. See, this one is the initial thing. We have created a set of integers, or sorry, list of integers, and we have doubled it in the map function. So these are all the doubled values of that lists. See what are all the elements we have specified in that list. 1, so 2, 5, 10, 8, 16, 6, 12, 3, 6. All are the double values of what we have specified in that list. Then coming to the next output, so we have specified who are all the students. So in that method, 6 student objects are getting returned. So up to this thing is the first system.out.println, that is this format, student details dot get all student details. From this list I'm going to create a stream, and each element or each object in that stream will get displayed. So up to this 6 entities belongs to this part. After that, what I have did is I have passed those stream of students to a map function for incrementing their CGPA. So let us see whether the CGPA or get incremented or not. So 8.67 is the previous value, and it will get incremented to 8.87. Okay. So in these are all the entities, those belongs to this thing. And coming to this one, we have incremented those CGPA, and we have passed those stream of students to a filter. So who are all having a CGPA greater than 8.7 will get passed out of that filter. So this 8.5, 8.54 or get filtered out in that filter function. Okay. Similarly, who are all belongs to IT department alone will get printed. So this is an example for reduce. There is sum of all those values, and this one is generation of series. 2, 4, 6, 8, 10. So I equal to I plus 1. So up to this thing 1 2 3 4 5 will get out of that stream, and with the help of map function I'm doubling it and I'm printing it. I have used system.out.print alone, so only it is getting displayed in a single line. If I have specified there system.out.println, all the things will be specified in an individual line. I hope this example is okay for you. Then so in this method we are going to concentrate on filter method alone. So what we have done here is I have created an array list of integer, and with that list I'm going to create or generate a stream. So with the stream of integer I'm going to specify a filter with one predicate value. So what are all the even values present over there, that will get counted and will get displayed. So see how many even numbers are there, 8 and 6. There are 2 even numbers alone. So at this point only 8, 6 alone will be presented in that integer stream, and those 2 values are getting counted, that will be returned out, and that will be catched by system.out.println. So this one is the similar example what we have seen in the previous program. Hope this one is okay for you. So let us see what is the output of this thing. So only 2 elements, 8 and 6. So those are the things that passes the filter test. Next, so in this reduce function, in this Java program, I have specified the functionality of reduce method. So what I have done is I have created a list of integers with this step, and I'm going to create a stream of integers. With that thing, I'm going to pass those stream of integer into a map method. So inside the map method, I have calculated the cube values of each individual element in that list, and that will get passed on to the reduce method. So what I have done here is, this is very similar to what we have seen in the previous example. That is nothing but I'm going to add those all the numbers in that strings. So what I am doing here is I'm going to create a stream of integers, and then I'm going to calculate the cube of each individual elements in that stream. After that I'm going to add all those cube values, and that will get returned as an integer, as I have specified the integer objects inside the stream. The result is also an integer depending upon my specification. So that will get printed over here. So what happens here means employee details dot get employee list will return a list of employees that will be converted to a stream. After that stream of employees will get passed to a through a map function or map method. So up to this point, the stream contains of a stream of employees. At this point, the stream contains only a stream of double values, because for each employee, I'm going to return his salary alone. So at this point, the stream contains only a stream of double values. After that, what I'm doing here is I'm adding all the employees 5% salary. So first I'm going to calculate 5% of each employee's salary, and that will be added together. For example, if we want to collect some fund for a particular occasion, some percentage of salary should be deducted from all the employees means, so we can use this method. How much of amount we are going to finally submit off, that thing will be displayed based on this specification. So by changing this value, we can differentiate different percentage in their salary account. I hope this example is clear for you. If you are having any doubt, you can mail me or WhatsApp me. And considering this collect function, in this method, I have created a list of employees with this function employee details dot get employee list, as this method returns a list of employees that will be stored here in the list list. So first thing I'm printing who are all the employees present in that list. After that, names collected as a list from employee details. So first what I'm doing here is, with that list I'm going to create a stream of employees. After that, at this point I'm going to generate a stream of string which is having the employee name alone in uppercase. So after that, a stream of string will get collected to a list. This n list contains only names of that employees in uppercase, and names collected in the form of set, names collected in the form of map with the specified key and the value. For each ID, the corresponding name will get mapped on. And I have displayed that map also. And this one is the example for grouping by in the collect method. So with the elist.stream dot collect method is going to group those employees based on their ID. So ID will be the key value and the employee will be the corresponding value. So once you got to see the output of this method or the program, you will identify what is what. So in this thing, I'm going to group the employee object based on their names, so that you will differentiate and understand what is the usage of grouping by. See, this one is the first thing. So these are all the employee list we have received from that function. Who are all the employees and what are those individual values of the corresponding employees will get displayed over here. And the second thing, I have fetched the names alone in that employee and displayed those name in the form of uppercase and collected those elements in that string to a list. So this one is the list output and this one is the set output. As we have already know, the set is unordered but list is ordered. So list get displayed the name of employees in the order we have created. You can see it in the output, but set is unordered and that is unordered and unique. It contains only unique elements. It won't allow any replicated values. So this is getting saved in a different manner depending upon the sets position calculation. Okay. So and this one is collecting those elements based on some map with the ID as key and name as value. So we have created a map, and finally these two are the outputs for grouping by. So this first thing is based on grouping by the employee ID. So employee ID is the key and the corresponding employee object is its value. Second thing, I'm grouping those employee with the help of names. Names as key and the corresponding employee object as value. I hope you are okay with the collect method. Then finally, those three functions, distinct, count and sorted. I have given individual examples for these three methods. So what I have done here is I have created an array of integer with the that I have populated with the scanner object. So I'm going to create an array of array list, not an array list. That is a collection list of integers I'm going to create, but I'm going to populate the list with the help of scanner object only. I'm going to get the input from the console, and after that I'm going to add it to the list. Once I got all the input, with the dot stream function I can create a stream of that corresponding list. So what are all the elements in that list I have displayed over here. So for each method can be supported for collections also, not only for streams, it is supported for collections also. Mention that only I have specified over here. So in the second thing, in this part, what I have done here is I'm going to sort the elements in that list and displayed it. In this thing, I'm going to find out what are all the distinct element in that stream. That is also I'm printing out it here. And finally, odd elements count. So the count should get varied, no? That's why I have reduced the number of elements in that stream by specifying a filter. That is, I have specified only odd numbers. Odd numbers can pass out of this filter method, and what are all the odd numbers present in that stream. So let me see the output of this thing. So enter the number of elements to be processed. Five elements. 1, 2, 1, 2, 3. So I have given here repeated elements also in order to identify the distinct methods functionalities. So what are all the list elements? 1, 2, 1, 2, 3 as I have entered here, and sorted list elements are, so this elements will get sorted, that will be displayed over here. So what are all the distinct elements, that is also getting displayed here. And finally, what are all the odd numbers in that list? 1, 2, 3. there are 3 odd numbers, and those count values will get displayed over here. Next thing, and the final one, is matching function. It is no match, any match. So in this example, I'm going to deal the list of students with the help of student details dot get all student details. This function returns a list of students. So with that list, I'm going to check first of all, I'm going to create a stream of students, and with that student stream, I'm going to check who are all, is there any match or is there any student in that stream who's having CGPA greater than 8.75. If it finds any match, it will return true. So I have specified this thing in an if condition. So if this thing is having any students who is having 8.75, or sorry, 8 point, any student is having CGPA greater than 8.75, then it should display there are distinctions in this class. Else there are no distinction. I have mentioned above 8.75 means those are all distinctions. So if we change this value, we can vary the distinctions range. So system.out.println, so there are no distinctions. If this condition gets failed means there are no distinctions in this class. So this is for checking who is there any toppers in this class. The second thing, it checks for the students' academic performance. So in this thing, I'm going to check whether the stream of students is all the students are having CGPA greater than 8.2. If all those things, all those students are having CGPA 8.2 means they are good students. Else they are all not good students, they are good in studies. Else I have to check if there is anyone is less than 5. That is anybody is having very low CGPA means I have to display poor performance. Or else if there is not, if there are some students are having CGPA less than 8.2 but all are having CGPA greater than 5 means students are having average performance, or they are showing average performance. So that is the example of this program's concept. I hope you understand it. There are distinctions in this class and their performance are good. What does that mean? All the students are having CGPA greater than 8.2. If we changed this value means we will get different output. There are distinctions in this class and average performance. So that's all about Java 8 streams. I hope you are okay with this video. If you are having any issues in understanding this concept, you can mail me or WhatsApp me. Thank you. Stay safe.